Okay, let's begin here. It's 8:30. So welcome everyone. This is Stat 873, Apply Multivariate Analysis. And there's something else after the name of it. I apologize, I don't remember the exact name. Applied Multivariate Statistical Analysis. People often just refer to this class as multivariate, so that's why the formal four-word name, I couldn't think of it off the top of my head. So, in case I didn't say this before, my name is Chris Builder. I will be your instructor for the course. I sent an email out yesterday via Canvas to everyone regarding where to download a syllabus that we're going to be talking about here today, and also where to obtain some introduction to our notes that we're going to be talking about here today. If by chance you did not receive that and you want to have a copy of it in front of you, you can go to my website, chrisbuilder.com. You notice there's no letter U in my last name, but it's still pronounced the same way as you might expect. And we can go to Stat 873, section Materials. There's, for example, a copy of where the syllabus is. Just the same paper, I don't print stuff out. And then my first set of notes that we're going to be talking about here today is our intro basics. Let me make that a little bigger. And so this projector is not necessarily the best, and it's a lot clearer on my screen than it is up here, but I think it's still readable. So anyway, so we'll be going over this R intro basics document later. Okay, so let's go ahead and take a look at the syllabus. So again, my name is Chris Builder. Please call me Chris. Don't call me Dr. Builder. Just call me Chris. I guess, especially for graduate students, I prefer to do that less formal way of addressing a professor. To give you a little bit of information about myself, I'm actually originally from Omaha. I grew up in the Millard area. I went to Kansas State for my PhD in statistics. My first faculty job was at Oklahoma State in their Department of Statistics, and then about 20 years ago, finally UNL decided they were going to start a Department of Statistics. And so I was essentially the first hire of the department back about 20 years ago. And I've been here ever since. Now overall, this is, I think, the 9th time that I taught this course, which is one of the most frequently taught courses that I've done. And the reason being is because there's a lot of really good information here that's directly applicable to a variety of different things. So I really like to teach this course. And so again, this is my 9th time teaching it. My office is in Hardin Hall, which is not too familiar with the campus. It's on the far southwest side of the campus, corner at it's the corner of 33rd Street and Holdridge. Trust me, at least the picture that I have on the internet, you can't see Holdridge down here where my mouse is. And my office is in the north wing of the building, so I'm not in the big tower part of Hardin Hall, and I'm in the far north, what would be the northeast corner of the 3rd floor. Okay. As for office hours, I think it's the easiest if we just meet, if you need to talk to me, right after class. In fact, we can just do it here, or there might be a class that eventually comes in after us. We can just go out to the hallway and talk. If you really prefer to talk to me in my office, that's fine. That's where I'm going next after I leave here. So we can go talk to my office. I'll be there till 10:45. And also, please feel free to make an appointment with me if you need to talk to me. There's my email address, builder@unl.edu. Please use that rather than communicate with me through the Canvas email system. It's just there are some things that are harder to do with the Canvas system, so I just prefer to just email me directly my unl.edu address. As for the course website, well, I just showed it to you. It's available through my website, chrisbuilder.com. We will use Canvas a little bit in this course for like quizzes and stuff that are automatically graded, but most of the stuff will be available on chrisbuilder.com. In terms of books for this course, there's no specific book that I require. I guess I've taught this course enough that I feel as though I can, through my course notes that you'll see shortly, I can really communicate the material better that way. And there's no book out there that does everything that I want to do. But still, it's good to have a second reference or second source other than my notes if needed. And so here are 4 different references for books. 2 of the books that I highlighted here in blue actually have free copies available through our library. You can download the PDF and just use it as needed. The prerequisites for the course, and by the way, I've done some highlighting and putting some stuff in red here, just because I wanted to make sure I remember to address that in class, so that what you downloaded obviously doesn't have the highlighting and text in red. Prerequisites for this course, Stat 801. But what this basically is an intro to statistics, where you talk about, well, what is a random variable? You do basic inference, such as hypothesis tests for a mean, difference of means, a variance, proportions. Do confidence intervals for those as well. Do ANOVA. Do regression analysis. So that's what we're talking about for Stat 801. Because I realize that some students maybe have gotten the equivalent, maybe at another university or through some other kinds of experience, but that's what we're looking for. If you're interested in knowing more exactly what's at 801, my course website, when I teach that course, is available, again, through chrismiller.com, Stat 801 there. You can see all my corresponding notes. Now, a strongly recommended course to also have before taking this one is a full semester of regression analysis, where regression analysis is taught at a level of using matrix algebra to do everything. So if you've ever heard of x prime x inverse x prime y, that's what I'm talking about for matrix algebra. Now, why do we have this recommendation? Well, the reason is, well, there's 3 reasons here. First of all, this can often be the first time that students see statistics presented from the standpoint of matrix algebra. We will use matrix algebra throughout this class. So that's why it's important to have that background beforehand. Also, Stat 873 covers regression-like models. So if you've had some regression analysis before, well, then that will help you succeed in this class. And then the third thing here, I put statistical maturity. What that just basically means is it's not, while it's doable, it's still not necessarily going to set you up for success as much if this is your second ever statistics course. This is a good third statistics, fourth, fifth statistics course. And so that's why I put statistical maturity there. So those are the recommendations. Now, since these are recommendations and they're not necessarily required, do note that we will have a short introduction to matrix algebra very early in the semester, in fact, next week. So if you're completely new to matrix algebra, we'll have an introduction to it, and you can judge at that time if, yeah, you feel comfortable with it or not. In terms of the grades for this course, we'll have 3 regular tests during the semester, final exam, and then we'll have some projects and quizzes. So the very first test, which will be less than a month from now, test number 1, you see it's worth only 5% of your grade. And the reason being is because this material on this test corresponds to what you can say is background material, what I would like you to have before coming into this class. And so we're going to spend a few weeks talking about this background material, like the matrix algebra stuff. And by only putting it as a 5% of your grade, this allows you to, first of all, just get a sense of, okay, how well am I prepared for this course? And if you don't necessarily do well in the test, it's not going to totally devastate your grade. And this is kind of a, you could say, it will help you realize, okay, you need to do more to get up to speed so that you can actually do the multivariate material of the course. And so that's why in this particular course, since we have students from a wide variety of majors, I like to put test number 1 early in the semester and only weight it just a little bit corresponding to everything else. It will with relation to everything else. So test 2 and test 3 will be over multivariate material, 20% of your grade each of them. A comprehensive final exam, 25%. And then I anticipate we will have 3 projects during the semester. These projects will be group work. And I'll help you, if you don't by chance know anybody in this course, I'll help you find a group member if needed. So 3 projects where you apply the stuff that we're talking about to some data. More so during the beginning of the semester, we will also have some quizzes, weekly quizzes, just to help get you going during the semester. And the way that these projects and quizzes work in terms of your overall grade for the course is only based upon this project's quiz as part of your grade. It's the total number of points earned out of the total number of points possible. Roughly speaking, right now, and it can change, I anticipate about 5 5-point quizzes during the semester. We will have 3 50-point projects during the semester, roughly speaking. So in total, that would be 175 points. So let's say you got 175 out of 175. Of course, that means 100%. And that is then weighted to be 30% of your overall grade. So if I were to, let's say, well, I will eventually, when I figure out your grade at the end of the semester, what I will do is simply take 0.05 times whatever grade you got for test 1, 0.2 times whatever grade you got for test 2, and keep on going all the way to the project's quizzes grade, 0.3 times whatever you get for that corresponding percentage, and then that will be your overall percentage grade for the semester. In terms of letter grades, just standard breakdowns that you would typically expect. I do plus and minus grades as well. These projects will be handed in electronically. In fact, there'll probably be no paper that you ever, there might be one thing where you have to actually hand it in to me on paper, but in terms of tests that we will do, it will most likely just be all electronic. So you're going to be handing all this stuff in an electronic format. Word or PDF is fine with me. If you haven't noticed already, I have a Surface Pro here, so I can use my pen to mark it up as needed. I'll use Word's tracking tool to track my comments, and then I can, email back to you any kind of graded item. But since some of this stuff, especially the projects, it can at times be a little bit long. You're going to really need to organize your write-up. As you will see, we're going to use R, the R code and output. You're going to nicely need to organize it. So please take the time to hand in what you're doing. Take the time to make it professionally done. No late projects or quizzes accepted. You'll have enough notice when the projects and quizzes are due. So that shouldn't be a problem. As I said, we will be working in groups for these projects, up to 3 people. So you're welcome to start thinking about that now, who you want to work with. Again, if you need help finding a group member, I will help you. The projects probably will not start until mid-September, to put it in perspective of when we start doing those. We will be using the statistical software called R extensively for this course. So we will not be using any other statistical software package. You do need to use R for the course. If you do not have experience with R, I'll give you a little bit of an introduction here shortly. R is available for free from these addresses there. I will plan to record all of our in-person class meetings this semester. So if you notice right now, there is just a simple webcam on a tripod. That's what I use to record everything. And so this is what's recording everything right now. Do note that this is wired to my computer here, so if after class you come up to my desk here, be very careful that you don't trip over the cord. Unfortunately, I've had that happen before with some students. Now, just because I'm recording these classes doesn't mean you should think, oh, it's 8:30 in the morning, I can't get out of bed, I don't want to go to class, I'll just catch the recording. No, don't think that. Just think of this as a backup if needed. If for some reason you're unable to attend, here's your backup. Also, here's a way to review the material if needed. The final exam, if you think 8:30 is early, well, final exam is 7:30 a.m. on Thursday, December 14th. So what do you need to do to be successful in this course? What are my expectations? Well, I've prepared an extensive set of course notes for our course. So you need to understand everything that's in there unless I tell you otherwise. There will be a lot of use of R. That means we're going to actually be doing some programming. We're going to be writing programs in this class to do the statistical analysis. So you do need to understand the code and the corresponding calculations. Now, with this R aspect, again, there's going to be a lot of code, but I'm going to be giving you lots of programs as well. And for almost everything that we're going to be able to do in this class, you can think of my program as a template for your own. So I might, let's say, write a program to analyze a particular data set that has variables x1 and x2. Then for a project, or maybe a quiz, or maybe a test, you need to analyze a different data set that has variables w1, w2. Okay, so you take my program, replace the x1 with w1, replace the x2 with w2. Those are the kinds of ways that we're going to be using R. Now, it's not always exactly that simple, but that's what I mean by I want you to think of my R code that I write as a template for your own. So there will be a lot of examples in my course notes. One of the first things that you should do then after a class when you want to start studying is try to reproduce the examples that I've done. Review the class recordings as needed. There's going to be a number of practice problems. These aren't anything that's graded, that's why it's called practice. Number of practice problems I'm going to have available for you that you can examine on your own if needed. And of course, please make sure to ask questions when something is not clear. Because if you have the question, probably somebody else in the class does too. So there's a number of other things that I'm required to put on a syllabus here at UNL. Rather than putting on this syllabus, I just simply have what's called a syllabus supplement that's downloadable from my course website in the same place where you just saw the syllabus. And so you can go ahead and review that as needed. One thing that I want to talk about, the test too, that might be new for some of you, is that all the tests will be done in an electronic manner. They will be, right now, I plan on them being in class. You will use the computers at your desk to do the tests. The reason being is because when you're actually applying these methods, well, you're going to be using a computer to do that. So it's helpful then to be able to for me to be able to assess you in that same kind of a format. The test will be closed book, closed note, but I don't want you to have to memorize our code. So what I will do is allow you to use any of the R programs that I've created. You'll see where to find them shortly. You can use those R programs in, again, as your own template when you do the tests. Okay? So that's all I have to say about the syllabus. Are there any questions? Okay. Does it feel hot in here? Yeah. Obviously, it's hot outside, but especially if you're fairly new to the university, you know that the university in the evenings and at night they essentially turn off the air conditioning and stuff like that. So well, I don't usually spend my evenings up here on campus. Last night I was up here about 9:30 p.m. I was in my office doing some work, and oh my gosh, it was rough because you can't breathe very well because it was so stuffy. Everything was turned off, and maybe since the beginning of the semester, somebody forgot to flip the switch here in Klein Hall and turn back on the air conditioner and stuff. So, okay. So the next thing that we're going to do is take a little bit of a closer look at the website. So, I was in grad school in the 1990s, way long ago. And ever since then, I've always constructed my own website for a course rather than using a course management platform like Canvas. And one of the reasons is because I always feel as though that like a Canvas doesn't allow me to do exactly everything that I want to do. And sure, I'll take advantage of Canvas for the stuff that I know it's a little bit harder for me to do. But otherwise, I'm just going to do it all myself. And also, I've learned a lot when I was a student and now that I'm faculty. I've learned a lot from looking at other people's course websites. So I know, like for Multivariate, there's a number of other course websites out there, and I've used those as a motivation for how I want to present the material here, or to get some other ideas. And so that's why I like to leave this stuff open, and you can see under my teaching part of my website here, I have a number of different other course websites that I use. And so to get to my course website again, chrisbueller.com, go to Stat 873, there's the course website. Section Materials, this is where you will find my course notes, my programs that I've written, the practice problems that I've put together, data sets that we're going to analyze, all that good stuff. And basically, about 10 years ago, I stopped using a textbook in this class. I decided just to basically write up my own material, which is kind of like a textbook. And I decided to break it up into 4 different parts. Background material, summarizing data, prediction, classical methods. Let me see if I can, there we go. And so let's talk about background material. And I kind of mentioned this before. This is the material that I would like everyone to understand before coming into this course. But for a variety of different reasons, that's not always going to be possible. So at the very beginning of the course, we go through this background material, and we have that test number 1 over it. And so we're going to start off with an introduction to R. Now with Stat 801 being the prerequisite, that should essentially give you the experience with R. It should. But I also know that some of you come in here without 801. You have maybe the equivalent experience somewhere else. And so that's why I spent a little bit of time at the beginning of the semester talking about an introduction to R. Some of this is going to be really simple for you, for some of you. Others of you, it may not be as simple. Rather than just immediately jumping into the material and skipping an introduction to R, what I have here basically is what I do the first week of Stat 801 with my students when I teach that course. So there are 4 sets of notes. They're in Word documents. That's when you see a .docx there. The first 3 is what I cover with my 801 students the first week of the course. This last part, this 4th set of notes, is what I do much later in the semester. Now, since I do this in Stat 801, and also I teach a number of other courses that it's helpful to have an introduction to R at the very beginning, what I've done is actually constructed a set of videos corresponding to these notes. So you can actually view those videos as well in terms of me going over some of these notes. We'll talk more about exactly what we're going to be doing here shortly with these notes. But you also have me going over them in a video format. These are just some videos that I posted to my YouTube channel. go over that. So you can simply click on those, download them to your computer. As for my notes, they are in a size 20 font. The reason why I use such a large font is that, no matter whatever classroom I'm in, they're going to be readable. That's why I don't use a size 20, like a common 10 or 12 font with these. So if you choose to, let's say, print off these notes, I recommend print them 4 pages per sheet of paper. Or you don't have to print them off and just simply edit them or take notes on them inside the Word document itself. Here's the corresponding R programs that are discussed in these notes. So if I just simply click on those, there's my corresponding R program. Perhaps this is too simple, but I know that sometimes students don't realize this. If I right-click on these programs and say Save Link As, this will save the program to my computer as well. Here are some data sets that we're going to be using with these notes. And then I also have some practice problems. Again, these are not graded. These are just give you some additional experience beyond what's in the course notes as well. I have partial answers inside of those practice problems. Then after that, we're going to spend a little bit of time talking about matrix algebra for those of you who do not have experience with it before. Not a whole lot of time, but just a little bit. I have some notes, I have some R programs and practice problems. And then lastly, we do data, distributions, and correlation. So we talk about what exactly is the kind of data that we're going to be looking at in this class. So the name multivariate corresponds to multiple variables. So in this data set, in this class, we might have a data set that has 3 variables, 5 variables, 10 variables, 20, 100 variables, multiple variables. How can we analyze those kinds of data sets? So we'll talk about some examples that we're going to be, some example data that we're going to be talking about this semester, some probability distributions that are helpful for us, and then also a review of what correlation is. Okay, so then we take a test. Section 2 here, summarizing data. So because we have so many variables, we like to be able to summarize that information that's available in our data corresponding to these variables, summarize them in some way so that we can make sense of them. Well, how can we do that? Well, as you might imagine, we can do some kind of statistical graphical method. A plot. A scatter plot. If you have 2 variables, plot one on the x-axis, plot one on the y-axis. Well, what happens if you have 5? What happens if you have 10 variables or more? How can you make sense of those variables and still be able to graph it? Can you do a 10-dimensional scatter plot? Well, no. But there are some techniques that you can use to still maybe use a scatter plot. But there's other kinds of plots out there. One of my favorites, a parallel coordinates plot that we'll be talking about. Then we'll also be looking at 2 methods that have a similar goal, principal component analysis and factor analysis. What that will allow us to do is basically come up with a linear combination of our variables. So let's say if you have 3 variables, x1, x2, and x3. There are optimal ways that you can find, let's say, a linear combination. Let's say 0.5 times x1 plus 2 times x2 plus 3 times x3, and you form a new variable from that. And maybe that new variable itself contains all the information, or most of the information that's in those 3 variables. And so now instead of looking at stuff in 3 dimensions, you could say, now you only have 1. And so that's what that talks about. Cluster analysis, what that corresponds to is you're looking for ways to, let's say, group observations. Observations that are similar to one another in some way. So again, that allows you to summarize the data and try to make sense of it. Then section 3, prediction. So note that I haven't talked about like a dependent variable, response variable at all, something that you're trying to predict, because that's what we do in section 3. You can have a response variable in section 2, that's fine. But section 3 says, okay, now let's consider a situation where I have some independent variables, explanatory variables. Let's try to predict a dependent variable. So an example that we're going to be looking in this class corresponds to football. I want to be able to predict, let's say, is a field goal going to be a success or a failure? How can I do that? And so we're going to look at a number of statistical techniques to do that. There's no technique that is best. That's why you don't just see one method up there. That's why we look at a number of different methods. And overall, something to think about in this class is that section 3 here could be a whole class itself, because there's so many methods out there. We can't talk about them all. Section 2 could be a whole class itself, but we can't talk about all those methods that are available to us to do this kind of stuff. So what I will do is pick ones that I think are good, pick ones that are popular, and that's what we talk about. Then lastly, section 4, classical methods. When I first started teaching this course 22 years ago, there was more emphasis on those classical methods. Like, for example, there's more emphasis on, all of you done a t-test before. Is the mean equal to some number? But what if you have, let's say, instead of just one mean, perhaps you have 5 means? Okay. Well, there's an extension to that. It's called the Hotelling's t-test. And so you can still do the same kind of hypothesis test, but for 5 means at the same time. And so that's what a classical method is. And so you can see there are some stuff here at the very end here where I don't have notes available. Well, that's because the notes aren't out there yet. I spent part of my summer basically going through all my notes, updating them and stuff. And fortunately, I haven't got to those parts yet. Okay. So let's take a look at the schedule. Note that the schedule here is subject to change, except for the tests. You're going to see some dates for when the tests will be. Those are the dates. So please make sure that you will be here on those days for the tests. The other stuff can change. So today, we just got done talking about syllabus. We're talking about the website right now, where we'll do a little bit of an R introduction. You see a thing here called video. This, after our class, is where I'm going to post a link to the video that I'm recording right now. Then there will be also I put, let's say, stuff that is important for you to know that corresponds to the date of the course or the class. Week number 1 quiz is due tomorrow at 5 p.m. It's going to be really simple. Don't get upset that I'm already giving you a quiz. We'll take a look at it shortly. So that's what we're going to be doing, or that's what we're doing today. Now Thursday, is a little bit of a different type of class. Again, coming in here, I know there are students with a variety of backgrounds. In Stat 801, if you would actually take that, you should have some introduction to R beforehand. But I do realize that there are some students who don't have that background. So, the way that I have chosen to do the introduction to R, that I've done it a couple times before in this class, is I make Thursday an optional class in terms of you don't have to attend it if you don't want to. In fact, I will have no material to present on Thursday. I'll just be here. I'll say, are there any questions? And so if you have questions about R, that's when you need to ask them. If you feel as though that you really know R before our class, don't worry about it. You don't need to come. You're welcome to, but you don't need to. But what everyone should at least do is before our class, examine those notes that I put together and the corresponding videos that I put together here before our class. If you do that, and you feel as though, yeah, I'm uncomfortable with this stuff, then it's okay. You don't need to come to class. But if you're not comfortable, come to class. Ask questions. the reason why, and there's two other ways I could do this. And the first one I've already said, and that is I could just assume that everyone has a background in R beforehand because 801 is a prerequisite, and we just go directly to the next part of the course. That would be one way. Another way is for me to take a few days in class to go through an introduction to R, but I know some students are going to find it just to be too easy and they're probably bored. And so I do kind of something in between where for those students who need the help, I'm available to give actual individual help during this class. So I'm okay that, if you just want to bring your laptop or use these computers here during the class, I can just simply go around the classroom and sit down with you to get you going on R. I found that to be helpful in the last couple times that I've taught this course. Okay, come back. Well, I do have a video set up here for August 24th. I guess it depends upon what we do, if it would be actually useful to have that video there. Then next Tuesday, we're going to spend one day talking about matrix algebra in this class. There will be a corresponding video. There will be a corresponding quiz due on that Wednesday at 5 p.m. And then on August 31st, we're going to start doing the data distributions and correlation section. Test number 1, September 14th. On your own after class, you can take a look at when we're going to be doing everything else. Again, this is an approximate. This is based upon when I taught the course, the very last time I taught the course, when we talked about certain things. Okay. So the graded web page is just going to, various projects that we're going to have, I will post them there. Tests will be posted there as well. And what we're going to be using Canvas for in this class, we'll be looking at, well, let's actually just look at it right now. So on Canvas, we will be using this for a discussion board, to take quizzes, and also at the very end of the semester, that's when I will post the final grades. That's the only time that I will actually post the grades, is at the very end of the semester. So let's take a look at the discussion board. So I've posted one thing here already, and what this does is just describes how we use the discussion board. So if you have a question about how to do a particular problem or project, or you didn't understand some stuff that was in my course notes, you had a question about it, post the question here rather than emailing it to me. Because again, if you have the question, probably somebody else has the question as well. And that way you can all learn together rather than learning separately. So post the question here. Do not email me the question. If you have a question about your grade or something that's really just about you, well, then go ahead and email me. If you're not for sure what to do, should I email Chris or should I post it to the discussion board? Just ask yourself, will other students benefit from seeing the question? If the answer is yes, please post it here.
When do you think we're receiving notification from this in our email? Because I didn't receive this.
Well, for this one, no, because I posted it a number of weeks ago.
Every time. You have to be sure that.
Well, you need to make sure that you're subscribed correctly to discussion boards on Canvas. And so there is an automated notification system that will do that for you. And so please make sure to do this, because this is the primary way that I will communicate with students outside of class. So like, for example, if maybe for some reason I'm sick, I can't come to class, I will post it here. So make sure that you are subscribed correctly. What I will do, because sometimes students are not, they may be fooling around with the default settings and they're not. So what I will do, let's say, about 5 p.m. this evening, I will post a message, like a test message, to the discussion board. If you do not receive it at 5 p.m., that means you're not subscribed properly. Okay? Let's take a look at the quizzes. So right now there are 5 quizzes out there. Let's actually take a look at it from a student view. There are 5 quizzes that are out there, and at the beginning of the semester we won't do any projects because you need enough background material first before we can do the project. So instead what I've done is I put together these weekly quizzes. This is actually the first semester I've done this in this course. And so the purpose of these quizzes is just to make sure that let's say you're on task, you're keeping up with what we're doing, and help identify maybe issues that may be stuff that you don't understand right at the beginning of the semester that you need to know for the rest of the semester, and maybe we can do some stuff to help out as needed. So that's the main purpose of at least the first 4 quizzes there. And this week number 1 quiz, which is due on Wednesday, 5 p.m., is actually not in regards to any of the material. It's just the typical thing that you often see in the first day of a class where, you know, an instructor wants to know more about the students. And so that's the purpose of this particular quiz. I want to know more about you. I want to know about your background, your major, your experience with R beforehand. That helps me then when I teach this course to know this. And also for future semesters as well, so we can have a better idea of how students are changing over time that want to take this course. So anyway, so question 1, just give me your name. Question 2, your email address. 3, your major, your degree pursuing, master's, PhD. Tell me also, question 5, what statistics courses that you've taken. Actually list them all out, please. Tell me about what the highest math course was that you took. So if you took matrix algebra before, include that. I mean, maybe you've even taken something higher than matrix algebra before. Let me know. If you've taken calculus, let me know. Do you have experience with R? If so, tell me about your experience. Was it in a particular course, or was it maybe something that you just kind of figured out on your own? I want to know your background. And this one's important. So, as I mentioned, for our tests, they will actually be here in the classroom. You'll be using the computers here at the desk. I want to make sure that you have enough time to complete the test. And obviously we have an hour and 15 minutes. And I will make tests corresponding to being an hour and 15 minutes long. But I want to absolutely make sure that you have enough time to take the tests. So I'm willing to start the tests early, if you are willing, or if you can. So if you want, I'd be happy to get here by 8 a.m. and have you start, give you an extra half hour. So let me know if you could start the test at 8 a.m. I think there is a class that comes in after us. It might be in as early as 9 a.m. It might be 9:30 a.m. And so we have to worry about that in terms of when we end. But if it's 9:30 a.m., I'd even be willing to even go extend the end time as well. But at the very least, I know there's no class in here at 8 a.m. So let me know if you could start it early. And tell me where you're from. I'm interested in knowing. So that's the last question. When you do this, make sure you click on Submit Quiz. That's the only way that I know that you've done it. It's the only way that I can give you credit. Overall, this quiz is worth simply just 5 points. That's it. In fact, all the quizzes, I try to make them just be 5 points. The other quizzes are usually just simply 5 questions. That's why it's easy to make it 5 points. Okay. So let's see where we're at here. So again, that's due Wednesday, 5 p.m. I think that's all I have to say about the website. Any questions about that? Okay. So let's next do part of this introduction to R. So if I come back again to my website, I know I'm going to repeat myself, but sometimes repeating is good, especially the first day. And what I'm expecting you to do before Thursday is to go through these notes, go through these corresponding videos where I discuss these notes. What we will though do here in class, since we have time, we got about a half hour, is I will just simply start going through this introduction to R in our class. And so obviously if you're looking at this corresponding video, you don't need to start at the very beginning of the video. And we might be able to get through this whole intro here.
Can I ask a question?
Sure.
So, based on what you said, there would be nothing surprising. And for example, we come here and it's like, today we have a quiz before the session or something. And we will have time to be ready for everything. And we will know that beforehand, yeah?
I'm sorry, I don't understand the question.
If you have any quizzes or tests, we will know that before coming to the class. It's not like the way that we come here and you decided to take a quiz randomly.
If you would like us to, we could do that.
No, I just
Everything will be clearly displayed on the schedule webpage.
Okay.
Okay, so you'll notice where the quizzes when they're due, and obviously I try to do it in a manner that's consistent. So notice all of them except for one are due on Wednesdays at 5 p.m. In Canvas, you'll also see, you'll get notifications about when the quizzes are due to. But everything will be listed here on the schedule webpage, so that there should be no surprises. If you are surprised about something, let me know, and I'll try to communicate the information better. Okay? Any other questions? Okay. So these introduction to R notes, actually I constructed them 3 years ago. And the videos are 3 years old. There are some small points, small parts of it, as you might expect that as software evolves, small things have changed, very small things. And I went through these over the summer to see, well, what's changed. And so if you see something that's like in a little yellow box, that's something that has changed. Okay. So R itself has really revolutionized statistics. So when I was in grad school, mid-90s, late 90s, everyone used SAS. SAS was by far the #1 statistical software package out there. One could say I grew up on SAS. I did my entire dissertation, almost all of it, using SAS. But then things started to change. February 29th of 2000 is when the first full-blown release of full-blown version of R was released. And what made it different from the SAS software that's still used by some people is that it was completely free. Also, it gave away that if, let's say, you're developing new statistical methods and you want to provide these statistical methods to others to use easily, the R software environment gave a way for you to communicate this information by creating what was called a package, which we'll see that shortly, which is, you could say, a group of ways to do this stuff, do the statistical methods in R. It allows you to create a package that is easily downloadable for anybody around the world to use. And so because of that, that's how R really took off. About the year, I think it was 2009 or so, there was a big article in the New York Times about R, how it was changing things. And that's often thought of as the landmark moment when R has gone mainstream. I started using R myself. Well, there was actually another software package that you had to actually purchase that was very similar to R beforehand. So I guess my experience started about in 1995, but I started using R itself in the year 2000. So R is free. The main website for R is cran.rproject.org. CRAN stands for Comprehensive R Archive Network. For many free software out there, there are similar types of websites out there. Like, for example, if you're familiar with what's called LaTeX, there's a Comprehensive Tech Archive Network, or CTAN. Well, here we have a CRAN for R. And it's not necessarily always easy to figure out, okay, where do I go on that website to download what I need to download? And so, at least for Windows here, in my syllabus, I also show for Macs. This is where you can go ahead and download R itself. The Windows version, just click on that, download your computer, go with all the defaults, and you'll get a 64-bit version of R on your computer. So then you can open up R, and this is what it looks like when it opens. Now, this might look different for some of you who have used R before, because you might be familiar with something that looks like this. Okay. What I'm showing you right now is what's called RStudio, which is the #1 way that typically people use R. And what RStudio is what's called an IDE, an Integrated Development Environment. Or you can think of it as, let's say, a program editor to use R. And so what they've done is basically embedded R, this company that produces RStudio, have embedded R into its own software package. This company came about 2010, 2011. And in my second set of Introduction to R notes, I show you how you can download this if you want to. Actually, I don't actually use RStudio. I use a different kind of editor myself that you'll see in the second set of R notes. But whenever I do an introduction to R, I always like to go back to the basics, because you don't need to actually use one of those programming environments. In fact, there's actually even an editor where you can type programs inside of R here itself. At least from my angle. Okay. From my angle, the text doesn't look good. But I think everyone can see it, right? Fine. So anyway, so you open up R and you get this. This here is called the R console window. This is where you can type commands to do your statistical analysis. And in fact, you can use this R console window as like a calculator. So if I do 2 plus 2, oops, that's not 2 plus 2. 2 plus 2, I get 4 back. But you can say it's a fancy calculator. Let's say I want a probability from a standard normal distribution. The probability that you would see often in class, probability Z is less than 1.96. Does anyone remember what that probability would be? Point what?
0.97.
0.975. And there we go. If I want to get a quantile from a standard normal distribution, let's say the 0.975 quantile. There we go. So what you see, and I could do, let's say, log of 1. And so what you see me here doing is using what are called functions. P norm is a function, Q norm is a function, log is a function. In fact, that's the natural log function that I'm using there. And so R consists of a number of built-in functions that allow you to do various calculations. Let me take a look back at my notes to see where I'm at. Now, you may want to be able to save the results that were just calculated from a function or just simply 2 plus 2. How can I do that? I can create what's in R called an object. So if I create an object called save, for the lack of a better name, save less than dash 2 plus 2. That less than dash is what's called making an assignment. I'm assigning the results from 2 plus 2 into an object called save. So if I type save, there you can see it's saved in there, and the value is 4. Now, that less than dash, the way it's verbalized is with the word gets, G-E-T-S. So I would say save gets 2 plus 2, or save gets the results from 2 plus 2. Oh, about 10 or so years ago, the people who control R decided to also allow people to use equal signs. So you can use equal signs, but still the less than dash is the most prevalent way of doing it. I always use the less than dash because it helps me see what's going on. What's on the right side is going into what's on the left side. So you can think of that as an arrow, that less than dash. Okay? If you ever want to see a listing of all the items that are saved as objects, well, you can use the ls function. ls parentheses and parentheses. Okay, let's talk some more about functions. So, again, we can do various calculations or work with our data using functions. So, let's say I just wanted to create a very, very simple data set. And we're just going to call it X. X gets, I'm going to combine 1, 2, 3, 4, and 5. So I'm using the C function. Formally, it's called the concatenate function. You can think of C as combine. I'm combining together these numbers that are separated by columns, by commas, and I'm putting them into X. So that's my data. Maybe I might want to calculate a standard deviation of this data. So I can use a function called SD for that purpose. SD parentheses X and parentheses. And so what happens is that the stuff that's in X is passed into this, there's some underlying code that does all the calculations for us, is passed into there, and then what's spit out, then is the standard deviation. How about we write our own simple function? And I'm going to write a function that calculates the standard deviation. I don't need to, since we already have that function there, but let's say I want to calculate I want to do my own. So I'm going to call it SD2, for lack of a better name. And SD2 is going to get, and to tell R that I'm writing a function, I use the word function. And as what we just saw here, I needed to pass in information or data into the SD function for the calculation to be done. So, for the lack of a better name, the information I'm going to pass in is going to be called numbers. And then we have some syntax here, parentheses, number, and parentheses. To start the main body of what's inside my function, I use a left curly bracket, and then I hit enter. Now notice that R comes back with a plus sign. Whenever you see a plus sign like that, that says, oh, you're not done yet. You need more information. So what do I do here? Well, now I actually put in, let's say, the mathematical formula for doing a standard deviation. I'm going to, I guess you could say, cheat a little bit and say, okay, I know it's the square root of the variance, so how about I use the function called sqrt for square root? How about I use the function called var for the variance? And what do I want to take the variance of? Well, whatever's in numbers. I need to enclose then my parentheses there. So var numbers calculates the variance, and then I can use the square root function, close that for to do the square root of what was from var numbers. Hit enter, and then R says, "Oh, you're still not done." Well, I'm done writing the content on my function, so I'm going to use a right curly bracket. Hit enter. Suppose I want to take a look at my function. This is one of the great things of R. Nothing's hidden. I can always, for all my functions, take a look at the actual code that's used for them. And that was one of the big revolutionary things when R was developed. If one was using SAS, you couldn't actually see what's called a SAS procedure. You couldn't see the actual code because that was all proprietary information. Here, nothing's hidden. And so if I do SD2, and then I pass in there what was in X. There's my standard deviation again. Any questions so far? Okay. Let's write a little bit more of a complicated function here. Suppose I want to print my data first, and then do the calculation for the standard deviation. And so this is how I can do it. I can use a function called cat. I don't know the origin of the name, why they use cat. But if you have a Linux background, you'll notice some of the stuff that I'm using here has corresponding, has similar names to what is in Linux. So there is a cat function in Linux that allows you to print stuff. There's an ls function that allows you to list files in a directory as well. And so to do this, to print my data, I'm going to say cat, parentheses, and then, well, what do I want to print? Well, I'm going to actually say print the data, and parentheses, quote, print the data, end quote. What do I want to print? Numbers. And then I have some stuff here that's a /n. For those of you who have experience with Linux, do you know what the /n does? It basically, whenever you use a slash there, that's what's called an escape character in Linux. Don't worry if you don't have the background in that. And then slash is an escape character, and then if you put an n there, it says, okay, go down to the next line. This is the only time that we're going to be using it this semester. And so print the data, go down to the next line. The data will be printed, then go down to the next line. Then do that calculation. So if I run this at what's called a command prompt in the console window of R, so wherever you see a greater than sign, that's the command prompt. Sorry, I didn't say that before. And if I do all this, I see print the data. And notice you see how the numbers went to the next line, and then also I have a blank line there. But still, the results for the calculation were saved into save. And so this is something that's very important in R to understand. Oops, why isn't my eraser working? I'll try this again. What's very important in R is this last line of a function. Whatever's in the last line of the function is what's returned to the user in terms of if I want to save the results from a function into like an object called save, that's what's going to be put there, whatever's in that last line. Okay. So there are going to be times where you're using R where you don't know what to do, you need help. So what can you do? Well, R has a number of nice help facilities within inside of R itself, in addition to just Googling what the answer might be. If I go up to here to help, HTML help. This is my favorite way to get help. I come to this web page. This is actually stored on your computer. That allows me, for example, to do a search, a keyword search. But what I'm going to do here is look at packages. Eventually, I'll be looking at packages. There we go. And so the way that R is organized is that there are a number of different functions, and they're all organized into different packages. And if I page down here, at the very bottom, you're going to see some packages that are kind of set off from the rest. These are the packages that are in a default installation of R. So when you download R and install it, all these packages, these groups of functions, will be there. The ones above are those that I've actually downloaded from the comprehensive R archive network because I needed to use them for some reason. We'll talk about how to do that shortly. Let's go back. And because of my experience with R, I know, like when we were using the pnorm function, I know that pnorm is in the stats package. So if I click on that, we see a whole bunch of functions available to do various statistical calculations. If I come up here to P, and then I come down to P norm, pass it. There we go. So there's P norm. So again, P norm allowed us to calculate a probability. The probability, a standard normal random variable was less than 1.96. So if I click on this, now we have help on that particular function. It gives us information about the syntax that's being used. It gives us information about, well, what are values that are returned. Notice, for example, here's the actual normal distribution, and gives us some nice examples to run as well. Now, I must admit, especially for new R users, this can at times be difficult to read. The text here is kind of terse. But let's take a look at P norm here. Now, you notice there's 4 functions listed there. P norm calculates probabilities with a normal distribution. Q norm calculates quantiles with a normal distribution, and so on. Let's take a look at P norm. And what this gives us is some information about the syntax that P norm uses. So when I used P norm 1.96, that 1.96 corresponds to what's called the first argument here called Q. Q stands for quantile. You can see, for example, if I look at arguments, Q is listed as quantile. So, if you're sometimes instructors don't use this terminology in intro stat course, but I'm going to use it here. This is a more standard terminology. The 0.975 quantile from a standard normal distribution is 1.96. The 0.95 quantile from a standard normal distribution is 1.645. So this Q tells us the very first thing that you can put into this function call is it has to be a quantile. And in fact, if I wanted to, I could say Q is equal to 1.96. And in fact, that's a better way to use R. Put the argument name equal the argument value. It's a good habit to try to do that as much as possible, unless you have some very, very simple function. But you can see here there are some other arguments as well. We'll just look at these 2 here. Mean, SD for standard deviation. Notice they have values that these arguments are automatically set to. These are the default values. So the default is mean is equal to 0, standard deviation of 1. In other words, so you can use the standard normal distribution. And if I wanted to, I can come back over here to R. Oops. Can't spell mean. There we go. And notice how I put the defaults in there. I get the same results. If I wanted to, I don't recommend doing this. I could do that as well without the argument names. That's not very descriptive, and it can easily lead to programming errors. By always putting in the argument names, notice what that allows me to do, though. I can change the ordering. I don't really care about the ordering, as long as I have the argument names there, which is different than from some other programming languages out there. Of course, I could change it. Suppose I do standard deviation of 10, and as you might expect, I get a different result. Okay, so that gives you some very basic background into the R help. Again, there's many different ways to get help. That's my favorite approach. Obviously, you can do a web search to get help as needed, but I think I like showing this way because it shows you how R is organized, and also shows you can always get the information this way. Okay. Note that you could also do help parentheses p norm at a command prompt, and that same browser window will pop up. Okay. So R, one of the good things about using R is that it is set up to work on what I will refer to as vectors of information. Meaning, let's say I combine together negative 1.96 and positive 1.96. And we combined together before 1, 2, 3, 4, 5. Suppose I do for negative 1.96 and positive 1.96. And I could find simultaneously the probabilities associated with both of those values through using the function just once. I don't need to use it twice. And so when I say that R is set up to work on vector information that's stored in vectors, you can think of it as the mathematical equivalent too if you want to. It's actually a little bit different, but if you've heard of vectors in math, you could think of it that way. R is set up to work on vectors of information. So let's look at another example. Suppose I create an object called X. It has, let's see now, 10 numbers in it. Suppose I create a vector called Y. It has 10 numbers in it. And let's say I just first display the numbers. Let's actually just go ahead and do this real quick. I can say X. There it's listed out. Now you might be wondering, well, why do I have a 1 here? Well, that's just the first element. It shows you where the first element of the vector is. So the very first value is 3.68. Now if I had, let's say, 100 values, what would happen is eventually it won't be able to keep on going to the right. So you might see like right below 1, you see the 10th value, and then that corresponding value will be listed. So the way that R works is that if I want to take X plus Y, I don't need to take the first element of X plus the second element of, the first element of X plus the first element of X plus this first element of Y. I don't need to do that separately. Instead, I can just say X plus Y, and everything's nicely matched up. So 3.68 plus 0.55 is 4.23. If I wanted to go inside that vector and get certain elements, I could say X left square bracket 1 right square bracket, and I get that value. I can do the same thing for Y. And so on. I could do the same thing for the second elements, but obviously that's a lot more time consuming to do. For those who have experience with other programming languages, you might say, well, if I want to take X plus Y, what I would actually need to do is write like a for loop or a do loop and go to the first element, go to the second element, go to the third element of these vectors and do it that way in terms of if I wanted to add the corresponding elements. You don't need to do that in R. Similar calculations, let's say I take X asterisk Y. What that's going to do is multiply each of the elements in X times the corresponding element of Y. So the first element of X times the first element of Y. How about I find the mean of X? Well, I can use a function called mean. And what if I take X minus the mean of X? Notice that X has 10 elements in it, but mean of X, as we just see there, has only 1. How does R operate? Well, what R does, it basically says, okay, now you're going to take 3.68 minus the mean. You're going to take negative 3.63 minus the mean. So in other words, it matches up. It tries to basically, you could say, well, in R's terminology, it's what's called recycling. It's going to make that mean of X match up with the size of X itself. And so that's how the calculations are done. If I take X asterisk 2, what's going to happen? Well, every element of X is just going to be multiplied by 2. Okay. So I think this is where we're going to need to stop. So make a note that we're at the very bottom of page 11. So when you take a look at the corresponding R notes, start at the very bottom of page 11 where we call packages. And you can learn more about these packages that we've briefly introduced already. Now, before we go, I want to say two things. Sorry, we're going to maybe go over just a little bit. I apologize. Even if you feel as though that you have a lot of experience with R already, definitely make sure you look at that last set of notes, because that's going to give you some stuff that some people miss who are new, who are even intermediate users of R. It's going to give you some information there that can be very helpful. It's about understanding what are called, or understanding why R is called an object-oriented language. Okay, very, very last thing here. Well, what's next for our class? I'll have office hours. We can have them in here. If there's a class that comes in, we'll just go outside the door. We can also meet in my office if needed. That week number 1 quiz is due on Wednesday at 5 p.m. Thursday, we will have class in here. It is an optional class for students. I will not have anything prepared. I'm just here to answer questions that you may have with R. I anticipate there will be opportunities where I can work with you individually during this class period as well. Tuesday, August 29th, we will examine the matrix algebra set of notes in this class. And then on Wednesday, August 30th, there will be another one of these quizzes due, and we'll be over R. Just 5 questions. Okay, any questions? Okay, that is all then here for today.